Hi, today we're doing 9-8 properties of logarithms. And yesterday in the notes I referred to 9-8 as being where you learned how that thing worked for finding the exponent, where the exponent equals the log of the answer divided by the log of the base. That actually, we go over the property today, but we don't actually learn it officially till section 10. So sorry for baiting and switching, so to speak. The book gives 5 properties, if I remember right. 2 of the 5 properties, if you go through, change the logarithm to an exponent, you can solve it in your head. Those 2 properties I don't bother putting in the notes because it seems like nobody actually uses them anyways, none of my students. But I want to put in 3 of them. And for these, then my first one, my first property, is if you have the log of x times y, base b. So if you have the log of, say, 500, you could break it up into the log of 5 times the log of 100. If you had the log of 25, you could break it up into the log of 5 times the log of 5. It used to be real handy back before calculators where you could just punch it in. My dad talked about, and I actually have his book with all different logarithm tables. And you say, well, log of 5 is what? You look it up. Log of 100 is 2. Then you'd have 2 point, whatever the log of 5 was. But I digress. So log of x times y base b equals log of x base b plus the log of y base b. The second property we're going to go over is that you have the log of x divided by y base b, and that's going to equal the log of x minus the log of y. And I should put a base b for both of those. Log of x base b minus log of y base b. Now if you're a memorizer, that's good. Life's great. If you're not, this is kind of how I've remembered it. If you think back to when we were talking about exponents, and we had, so I wouldn't put this in the notes, I would just kind of watch. But when we had something like x to the 5th times x to the 3rd, we saw that, well, what do? You take those 2 exponents and you add them. So that's going to be the log of 5 plus 3, or the log of 8. That's essentially what we're doing here. If you think back to the definition of a logarithm is really a fancy way of writing an exponent. That when you have a logarithm, say this logarithm here, what that equals is the exponent, because it'd be b to some power equals this. So a logarithm really just is an exponent. And if you think about it, multiplying 2 numbers, what do you do to the exponents? You add them. So that's maybe one way to kind of remember it there. Here you're dividing 2 numbers. So if you have 2 numbers with exponents, what do you do to the exponents? You subtract them. So I don't know if that helps or not, but for me at least, that was a good way to help me remember the properties. The last one that we're going to look at is if you have log of x to the n base b. And for that, that's going to be n times the log of x base b. For me, I just kind of look at it visually, that you could view it as though, well, this n here goes and gets plunked down in front. That's helped me remember it. If you kind of want the little caveat off on the side, I mentioned before when I had that log of x times y base b, the first one, that if you had log of 25, you could look at that as though it's log of 5 times 5 base b. Well, that'd be the log of 5 base b plus the log of 5 base b. And that's the first property. Well, that fits for this third one. If you had the same thing, we had log of 5 squared base b, that's going to be 2 times the log of 5 base b. So you see how you get the same answer no matter which one of those properties you use. You could either add the 2 together, which would be like x plus x is 2x, or you could do 2 times one of those and get your 2x that way as well. Alright, moving on. So main thing, learn the 3 properties. If the stuff in green kind of lost you, don't worry about it. Sample ACT questions. So pluck these from some old ACTs. This thing here, if you're trying to solve this, well, we're trying to figure out what that equals, so I'll make that equal to x. If you're ever stuck with a logarithm, change it to an exponent. So we have 2 to the x power equals 8. And I'm hoping that most people would just look at that and be like, oh, it's 3. So the answer then would be F. Otherwise, you could use the exponent's going to be the log of the answer divided by log of the base. So it also would be x equals log of 8 divided by log of 2. And as long as you end your parentheses here, your calculator probably puts a parenthesis there for you. You should get the right answer if you punch it in. This one here, it's real tempting to look at and say the answer is 8. It's like, oh, that's property number 2 that we just talked about. When you're subtracting logarithms, that's going to be the same as the log of 24 divided by 3 base 2. But unfortunately, that doesn't work here. Well, that would be true, but that's not the whole story. You can't just say your answer is 8. I got a little bit ahead of myself there. So anywho, this property here, you can say that's the log of 24 divided by 3 base 2. I'll put that in parentheses. So that's the log of 8 base 2. So your x would be 8 if on the right side of the equation you also had base 2, but instead they gave us a base 5. So we need a little more room here. So this here is essentially the same problem as up above. That if you just take this left side, well, what does that equal? Maybe I'll say my left side then equals y. So if that equaled y, you could say, well, 2 to the y equals 8, and then so this whole side then has to be a 3. So essentially my problem is 3 equals the log of x base 5, and now we're just solving for x. We got rid of one of our logarithms. If you're ever stuck with a logarithm, change it to an exponent. So I'd have 5 to the third, so this to the answer power equals x. 5 to the third is 125. So D is going to be the answer. The questions I ask in class usually aren't quite up to this caliber, where here it's kind of like a multiple step thing. Here are some of the questions that you're more likely to see from me. I would encourage you to pause the video, copy these down. I'm going to go through them pretty rapid fire. Alright, hopefully you copied them all down by now. Alright, so this first one, we have log of 12 base b plus log of 2 base b, and when we have that, the addition here means that we take and multiply the 2 and the 12, so it ends up being log of 24 base b. This one here, it's subtraction. Subtraction then means division. We divide those two numbers. So 18 divided by 3 gives me 6. So the answer will be log of 6 base b. This one here, I look at it as though you can take the exponent and move it to the front, or you can take the number in front and move it up to the exponent. So now we have a 2 to the 4th. 2 to the 4th then should be 16. I just graded the test on this chapter yesterday, and this one here I probably had about a third of the people get wrong something like this, and it's an order issue more than anything else. In this case, it's at least like one of these last two, I should say. In this case here, because we have the parentheses, we need to combine the 2 and the 8 first. So this problem becomes 3 times the log of. It's tempting to add the 2 and the 8, but adding the logarithms is like adding exponents. You do that when it's multiplication. So we have 8 times 2, so we end up with log of 16 base b. Then from there we go through and we do 16 to the third power, so 4096. The last one, because we don't have the parentheses, we need to do it in the other order. And now the question here comes also, the 2, the exponent, that's what is it to the second power? So let me make a little bit more space. If we had parentheses, then we'd have to combine them and then go to the 2, but we don't. So in other words, it's just 2 times this first logarithm right there. So in other words then, the 2 ends up being up here. So essentially the question turns into this. Log of 12 squared, or log of 144 base b, minus the log of 4 base b. And now, because we did subtraction, we're going to do 144 divided by 4, and that is 36.